Hello, Mr. Fry's Algebra 2 class. I'm taking a look at this normal distribution worksheet. Get to the beginning here. One thing that you might want to refer to is, I got this online, and just taking a look at this data, don't worry about these numbers down here because it was asking about some other questions. So, don't worry so much about these, but the divisions of the normal distribution, if this is 68%, that means this little part here between the median and the next standard deviation is 34% and 34. So you have 34 and 34. So that, if you subtract that from 95, this leaves you with 13.5 on this side and 13.5 on this side. If you subtract that all, the 95 from the 99.7% from this to this standard deviation, all of this, that leaves you 2.35 and 2.35. And then all the way from 0 to 100% of all the data, you would be left with 0.15%, 0.15%, because it's 0.3% from here to here that's left, 0.3, which is 0.30, which is split up into 0.15 and 0.15 in a normal distribution. So taking that information, we are going to use that in answering these questions, okay? So let's take a look at your number one. If the mean life of a tire is 30,000 kilometers and the standard deviation is 2,000 kilometers, what's 68% of all the tires will have a life between what? So that middle 68%, when you do your standard deviation, here's my number one, sorry. I know it's kind of ugly, but this is the 30,000, just add 2,000, subtract 2,000, subtract 2,000, subtract 2,000, okay? So this is 32, 34, 36, sorry, it's a little bit scrappy looking, but so from here to here, that's that 68%. Okay, so that would be 28 to 32,000. And then 95%, so that 95% data, so you go 2 standard deviations above, 2 standard deviations below, so 2 above, 2 below, so that's between 26 and 34,000 kilometers. And what percentage of the tires will have a life that exceeds 26,000? That's going to be 97.5%, because more than this. So I'm adding, and I'm using this data right here. So I'm actually going from this standard deviation and adding all these percentages up. So that would be 13.5 plus 34%. Plus 34% here, plus another 13.5, plus a 2.35, plus a 0.15, and that gives me 97.5% are going to go beyond the 26,000 kilometers. If a company purchased 2,000 tires, how many tires would you expect to last more than 28,000 kilometers? Well, more than 28, so I add up all these percentages. So that's 34, 34, 13.5, 2.35, and 0.15. Added them all up here. That is 84%. And I just do 0.84 times 2,000. I get 1,680. So 1,680 for that one. Okay, so we set it up. We have to construct a normal distribution curve. So set up your curve. Okay, this is my curve. So I have an extra line in this one. Don't pay attention to that line, please. I went a little too close. So our our median is 12, and our standard distribution is, or standard deviation, sorry, is 4. So no, 3. I'm looking at the wrong one. So 3. So plus 3, plus 3, plus 3, minus 3, minus 3, minus 3. Okay. About what percent of the products last between 9 and 15 days. So between 9 and 15. 9 and 15, that's going to be your 68%. That's the 68% of data. Okay. About what percent of the products last between 12 and 15. So just 12 and 15 is going to be half of that 68, which would be 34. half of that, 68.34. About what percent of the products last 6 days or less? So 6 days or less. So that's going to be these last two little sections. So those last two little sections are 2.35 and 0.15, which adds up to 2.5%. About what percent of the products last 15 days or more? So 15 days or more, so these 1, 2, 3 sections, so 1, 2, 3 sections, 13.5 plus 2.35 plus 1 plus 0.15, that ends up being 16, so that would be 16%. Number 3, a line for tickets to a local concert had an average wait time of 20 minutes and the standard deviation is going to be 4. So set up your standard deviation curve, okay? Or your normal distribution curve, sorry. And so 20 plus 4 plus 4 plus 4 minus 4 minus 4 minus 4. All right. So what percentage of the people in line wait for more than 28 minutes? So more than 28 is going to be boom, boom, these two sections. So I have a 2.35 plus a 0.15. 2.35 plus a 0.15 is 2.5. So 2.5%. If 2,000 ticket buyers were in line, how many would you expect to wait for less than 16 minutes? So less than, so it's 1, 2, 3, these three sections. So 13.5 plus 2.35 plus 0.15, that's 16%. The only thing I didn't do, I notice here, 16% is 16% of, how many did they say? 2,000, 2,000. So I got to do 0.16 times 2,000. And that's going to give me 320. So that's going to equal 320 people that were expected to wait in line less than 16 minutes. What is the probability that a person waited at least 16 minutes? So at least 16 is going to be all these sections. So that's 34 plus 34 plus the 13.5 plus the 2.35 plus the 0.15. Once again, I'm getting them from this curve here. And those percentages that I talked about earlier, that's 84%. That's 84% is the probability of that happening. Okay, in an Oreo factory, the mean mass of a cookie is given 40 grams. For quality control, the standard deviation is 2 grams. So set up your normal distribution curve, okay? 40. And add to, minus 2, minus 2, minus 2. All right. So if 10,000 cookies were produced, how many cookies are within 2 grams of the mean? So 2 grams of the mean, so that would be 38 and 42. So right in between those, that would be 68% of the data. 68% of 10,000 is going to be 6,800. For B, cookies are rejected if they weighed more than 45 or less than 36. So more than 44, sorry, not 45, more than 44, less than 36. So it's these two and these two. I added them up. That's 5%. It's 5% of 10,000 is 500 cookies. They can send those cookies to me, the heavy ones and the light ones. Okay, C, how many standard deviations away from the mean is an Oreo that weighs 49 grams? 49 would be, 1, 2, 3, it's out here, so I'm going to say 4. Okay. And what is the probability that a randomly selected cookie weighs between 36.3 grams and the 50th percentile? Well, I ended up with 45.475%. Not 100% sure about that, but let's take a look at what I did. 2 standard deviations was 13.5, or those, not 2 standard deviations, 36. Okay, so the difference between the 38 and the 32, I'm just trying to find out what percentage this is because I know that this is going to be my 34%. So this is from here to here, 2 grams, not standard deviations, 2 grams was 13.5%. So I have 1.7%. Because 38 minus the 36.3 is 1.7, is to what percent? So that ended up being my 11.475. Because I couldn't use the full 13.5 because that goes all the way down to 36. They want 36.3. So I had to adjust that. Plus the 34, this section would be 34. That gave me the 45.475%. For number 5, set up your standard, your normal distribution curve. All right, and we have 75 being the mean score and the standard deviation of 15. So plus 15, plus 15, plus 15, minus 15, minus 15, minus 15. Okay, how many students have the score between 45 and 90? So between 45 and 90. So we have this 34 and 34, which is 68, plus we have this 13.5 down here, that 13.5, plus the 68. So those sections equal 81.5. They want to know how many students, though. 81.5% of 1,000 is 815. So I just took 0.815 times 1,000, and I get 815. So that's 815 students. If 60 is the lowest passing score, how many students are expected to pass the test? So if 60 is the lowest score, how many students are expected to pass the test? Actually, these are 16% are, this would be fail. I misread that. So let's just do 100 minus the 16. So that would give us the 84% are expected to pass the test. And 84% of 1,000, that would be 0.84 times 1,000 equals 840. So 840 would be passing. So 840 are expected to pass the test. I really hope this helped, and I hope I led you in the right direction. As I was just I haven't been in the class, but I've been using these notes that I found online, and hopefully that is helpful to you. I know this normal distribution was really helpful in breaking it down into each section, so I could add up the sections and figure out the numbers. So if you need more help, please let me know.